Let's look at even-odd functions. Hi, and welcome to Algebra Examples. I'm Dr. Finch. Let's dig into this problem for today. We're looking at the function f of x is equal to x minus 3 quantity squared. So there's a parentheses there. That's going to make a very big difference in our lives. Before we move on even further, let's remind ourselves what it means for a function to be even or odd. So functions can be called even, they can be called odd, or they might not be even or odd. So it can be neither as well. We'll start off with the definition for even. A function is even if f of x is equal to f of negative x. So it doesn't matter whether you put in, for instance, the number 1 or the number -1 into your function, you're going to get the same exact output. And we can see this graphically rather than algebraically. If we look at it, it is going to be symmetric around the y-axis. So I'm going to draw up a little picture here. We use the word even because some of the functions that are even have the look y is equal to x squared, or y is equal to x to the fourth. When it has a power that's an even power, most often it is an even function. But there are going to be some exceptions, in which case we're going to find out, like, once you muck with your function a little bit, it may not exactly be even. The other one that we're going to look at are odd functions. And we say a function is odd if our function is equal to negative f of negative x. And these functions are symmetric around the origin. And if you're looking at just a basic power function, those ones have the shape of this. Y is equal to x cubed, or x to the fifth. And again, that exponent is kind of a giveaway of what you're going to find. All right. Not every function is even or odd. We don't have, or it's not just polynomials that are even or odd. We can have trig functions. Some trig functions are even, some are odd. Let's go back and apply this to the example that we're looking at and see if we can figure out what's going on. So notice we have f of x is equal to x minus 3 quantity squared. So we see that squared up there, which kind of indicates this might be even as a function. So let's check out and first see, do we think this is even? So we're going to actually plug in to our function. Remember, our function is equal to f of negative x if it's even. So we're going to see what happens when we plug a negative x in where we see x. And we're going to pop that in. I'm going to use parentheses so that it looks all nice and cute. Now, it's not clear at this point whether these functions are the same or not. It's too convoluted at the moment. So what we're going to do is we are going to rewrite it. We're going to do our algebra work here to see if they are actually going to be even or not. So we are multiplying negative x minus 3 times itself. We're going to distribute through everything. So we are going to have negative x times the negative x. And I'm going to keep parentheses around everything, just so that it all looks nice and so that we don't lose ourselves somewhere as far as what's addition and what's subtraction. Because a lot of these negative signs, as we're going to see, in fact, all of them, are going to cancel each other out. Okay, so first off, we have negative x times negative x. When we have a double negative, they cancel each other out, so we end up with x squared plus, now again, in this next term here, we have two negatives, so they cancel each other out. And we end up with 3x. I'm going to put the 3 in front because we kind of like to have it that way. Next term, same thing. This ends up being 3x. In our last term, 3 times 3 gives us a 9. And again, those negatives kill each other off. So we end up with x squared plus 6x plus 9. Now, again, at this point, it's not clear. Is this the same thing as our original function or is it different? So let's actually write out our original function, x minus 3 quantity squared, and let's distribute that out. We're going to take, and I do like drawing in my arrows. It just helps me remember that I've got to have 4 terms when I multiply this out. A lot of times, if we don't do this little bit of extra work, we do get lost sometimes. So we get x plus x times a negative 3 plus a negative 3 times x plus negative 3 times negative 3. And you'll see again, I'm using parentheses and I'm just adding everything and throwing the negatives in with whatever number they're attached to, which in this case is all 3's. But to do this, now we notice some things cancel and some things don't. So our first term is x squared. Our second term this time ends up being minus 3x because we only have one negative sign there. Same thing for our third term. It's a negative 3x. Our last term, we have 2 negative signs, so it's going to be a positive 9 because those negative signs cancel each other out. We end up with x squared minus 6x plus 9. And you'll notice that these two are not the same. So this is not an even function, despite the fact that it's got the squared up there. Because we modified our function on the inside before we squared it, it's not going to end up the same. And we can actually do a little bit of a test case to double check as well. What happens when we punch the number 1 into our function? We get 1 minus 3 quantity squared, which is negative 2 quantity squared. Negative 2 times negative 2 is 4. If we put negative 1 into our function, we get negative 1 minus 3 squared, which is negative 4 squared, which is 16. And again, these two numbers are not equal. So this function is not going to be symmetric about the y-axis, which means that it is not an even function. And we don't have to do much to note that it's not going to be odd either, because if we put a negative f of negative x, we can just take our output for our f of negative x, which was x squared plus 6x plus 9. Distribute that negative sign. And this is not the same as f of x. So it is also not odd. So in other words, our function that we were given here is neither even nor odd. I hope you learned something today, and I'll see you again.